So in this video, we are going to cover about the thread. So let's first discuss what is thread. So we can take an example to understand the thread. Let's say you are working in a team where there are multiple members. Each member is given a task to do something. Okay, for example, you are given a task to create a button. Your other team member would be given a task to do something else. So in that way, if we think, each one of you is working as a thread. There is a process or there is a project which you need to complete, and each of that project has been divided into multiple sections or multiple instructions where every one of you as a member is given some instruction to get executed. And if so, think in that way. In that situation, you all guys are working as a thread. So you can always, so what we can say is thread is the smallest unit of execution within the team, because you are the actual person who is going to execute those instructions. So you are the smallest unit of the execution within that process or a project. So what is thread? As I mentioned, is the smallest unit of execution within a process. Process can be something, a large thing which we need to do, either let's say even making a HTTP API call. Just making a HTTP API call require multiple steps to be executed. Either you can just use one thread to execute all those steps, or you can generate multiple threads who can, or where you can divide the task of doing the same thing, and you can do it more faster way if the system allows the parallelism and or concurrency. Okay. Now we can take an example of making a pizza. I'm sorry, making a sandwich, let's say. Now when you're making a sandwich, what you first do is you put the bread in the toaster, then wait for the pop up, then you start preparing other ingredients. So in that way, you as a person is working as a thread there. You are following a sequence of instructions, okay, and you're trying to complete that task basically. Now we will be discussing more other things like, hey, how the multi-threading works, what is concurrency and parallelism. But for now, you can just consider that basically thread is the smallest unit of execution which is done within the process, and it is just about having some instruction, some a small unit of instructions is provided to that particular thread which it needs to complete basically. Okay. A process can have more than one or two threads, as we have just discussed, and every thread can operate independently and can execute different part of the programs concurrently. We will be discussing currently um, parallelism and all that thing in more detail once we reach to that stage. For now, we can just say we can just keep it till here. Now let's talk about this how we can implement it basically. The threading or thread can be created by two way, either by using this thread class. Okay, it is actually already in the JDK, and again by using this runnable interface. Okay, now let's first discuss what is this thread class, like how we are going to actually create the thread by using this thread class which is given in the JDK. Okay, let's come to here. So this is the same code I have copied from here. Now if we run it, if we see, as you can see, what we have done is we have, sorry. So what we have done is we have created a class called my thread by extending the given JDK class, which is already present in the JDK, which is named as thread. In that, we are implementing this method called run. Whatever you want to do in the thread, whatever steps you want to be followed, whatever the instructions you need to be executed, those always go inside this run function. For example, if you want to create something, if you want to add something, if you want to log something, whatever, any instructions which you want to get executed by that particular thread goes here inside this run function. Okay, this is how you have created the thread. Now how you are going to use it and call it, if you see here, first you have just created the instance of it, and you always call it by using this dot start. So thread is having a life cycle basically. It is like start, stop, run, and all those things. Now let's actually see what happens when we say thread one dot start. Let's go to the code of this thread class itself. So in this thread class itself, if you see, this thread function is written. Sorry, this start function is written with synchronization. We will again discuss about this synchronized word in upcoming videos. For now, you can just ignore it. Okay. Here, what is actually happening is first we are just making a corner checks about the thread status. You can ignore this line also. Now let's directly come to here. What we are actually doing here is the start zero. What this start zero do is this start zero is about creating the thread on the OS. All the threads are managed by the OS itself. Okay. So if you are generating a new thread to execute some steps, first you need to create that thread and that needs to go through the OS, your operating system. Okay. Now for that, this call is happening, the start zero, this one. What this do is this create a thread on the operating system. Once that is created, once that is created, the Java virtual machine, you can just say a software where this Java code is running for now, automatically runs this run function. Automatically runs this run function. Now the question may come up that hey, why do we need to get a new thread? We can't we use a same thread? But the whole point of doing this is creating more threads. If we do not do the start zero, no, then all these works will be done within the same thread. But that is not what we are looking for. We want to generate two new threads and assign that these works to them basically. Okay, so this is how it is actually working. In this run function, what we are actually doing is we are printing this thread dot current dot get name. So this name which is coming up, it depends on the JVM or implementation or JDK or on the OS. So it can be anything, but it will be basically uh, kind of, I would say, unique or something like that. Okay. Here, what we are doing in this is just a simple implementation which we have created to showcase you how the thread works. We created two thread. Now the thread are going to sleep after every 1 second, basically. Okay, and then they again wake up and then they again continue the same process. Basically, that's why you are seeing thread 1 0. Then after some point of time, thread 1 1, then thread 1 2, then thread 1 3. If I run it again, you will see there will be a gap. There will be some latency. Yes, I see. Waited 1 second, waited 1 second, waited 1 second, waited 1 second. Okay, so this is how this entire thread is actually working in terms of implementation. Okay, this we were talking about this one. I think we have already discussed about all this. So if we see about this one, so these both the threads, thread 1 and thread 2, execute concurrently for printing the numbers from 0 to 4 in the respective thread. So what is actually happening is basically this thread 0 gets started, this thread 1 got started. First it kind of logged the value of this one and it thread 1 also logged the value. They both went for the sleep. After 1 second, thread 1 again logged the value. Sorry, thread 0 again logged the value, then thread 1 again logged the value. That's how they're working concurrently. But as I said again, we will be covering the concurrency more depth in the upcoming videos, not here. Here it will be too much actually. Okay. So this is just how the just a picture where you can visualize how this actual entire code is working. So if you see here, sleep for 1 second. In every single loop, the thread is going to a sleep for 1 second, and then again it is actually printing this number. If you see this line, this one. Okay. Now let's come to this runnable interface code. Okay. Let's go there. Yeah. Now same thread can be created by using this runnable interface. One interesting thing which I want to show you, the thread class which is implemented in JDK itself, internal code, it's again also implemented by extending the interface. Here, if you see. Okay. Now the question may come up, hey, then why we need the board things and all that thing. We will discuss about all those parts. So here if we see, the thread which we have used previously was a class, but this runnable is an interface. Okay. So now in this interface, we just need to implement this method, which is called run. Okay. The run is again doing the same thing which we have discussed in the previous example, nothing different. Here in this main function, the difference is we have provided this runnable interface to thread 1 or thread 2. Okay, now the difference between the thread and the runnable interface. Thread have a life cycle. Okay, it has a start, stop, sleep, and all those things. But runnable is only about that, hey, these are the instructions which I want to run. That, hey, these are the instructions which I want to run. It does not have any life cycle at all. So whenever you are going to create the runnables, you are always going to use it this way, basically. Okay, you provide the runnable, you say that, hey, create the thread, and these are the instruction which I want to run actually. What is going to be the work of thread 1? That is what you are actually providing here. That, hey, thread 1, you need to do this work. Hey, thread 2, this is what you actually need to do, basically. Okay. Now, if you would have created single class, you could have think of now that, hey, if you would have created single class to do different work, we would require to create different thread class. Okay. Instead of that, we can just create a runnable and we can provide it to any thread to get executed. You will get to know why this makes more sense once we start understanding more about the thread pooling and other way of creating the threads. Okay. For now, we can just keep the things till this point here. That, hey, this is how also you can implement the thread. Although it is, again, as I said, it is still same, but again it matters when you're going to write the code in terms of designing and how you are going to use it. Let's come here. Okay. And in this example, so basically we have just discussed about those things here. Nothing different. It's going to work uh, the same which we just discussed previously. Okay, and nothing much difference here. Let's see. These are the output. So this is how we have given the sequence diagram where you can see how it is actually working. So if you see here, we have created the instance here, but this is the thread 1 and thread 2 actually. So this one, thread 1 and thread 2 is exactly similar to this one basically, this thread 1 and thread 2. You will not find any difference there. Okay. Now what is thread pool basically? Okay, now let's discuss. So what normally happens is, have you guys thought about that? Hey, we are creating a new space. The space is limited actually. So the space is limited. Let's say 100 GB. Okay, we have 100 GB of space basically. Correct. Whenever you are creating a thread, it is always taking a space in the RAM. Now in this case, as you saw, the work of this thread 1 or thread 2 was done actually after this function is done. So do we still need to fill that memory? No. So that memory need to be freed. What does that mean is, whenever we are using any memory, so we make a check that, I'm just telling it on one kind of on a very high abstraction, that, hey, this memory is already getting used. Okay, now since the memory is not in use, we need to make sure that same memory can be used by someone else. Correct? So someone needs to do that cleaning part. That cleaning is actually done by a thing called garbage collector. For now, I will again keep it abstraction. We are having something called garbage collector, which keep clean the memory which are actually not in use. For this example, in this example, we created two threads. We took these two threads are taking some spaces. Now that spaces is not required. So the garbage collector or a tool will mark those memory usable. That, hey guys, you can use this memory. We are done with this. This memory is not used anywhere. Okay. So all this part is done by the garbage collector. Again, we will discuss in depth about them again. Now, whenever you create a new thread, as we have seen here, whenever we create a new thread, we actually need to create a thread at the OS level first. So don't you think that requires some time? That requires some overhead. Basically, it's definitely going to take some time. It may be a nanosecond, millisecond, where it may be nothing, but still it is going to take some time. So creating the thread cleaning it, creating the thread, cleaning it. There is always, we are wasting the time in that process. Can't we save that time? Can't we say that, hey, we will reserve, let's say, 100 or 10 threads for our work, okay? And we will keep using the same thread all the time. Let's say you use two thread. Now you are not using those two threads at that point of time, but that does not mean you will release those two threads. You may require it in the upcoming instructions. So you will still keep those two threads under your count. That, hey, still it is 10. And whenever you want to have a new thread, you will assign the threads from your object pool, basically. That is what pooling means. What we actually do is we create a pool of some number of the threads, so that, let's say, a task came up, hey, I want to create a file that requires a thread. Now you will ask the pool, hey, pool, give me a thread. So this is a pool. You can say it contains 10 thread. It will say, give me one thread. Okay, so one thread is gone here. Give me one thread. One thread is gone here. Once they are done, then thread will be again released to the thread pool. Now, if any other task come up and they want to use a thread, they can call those threads again for the usage. In that way, we are minimizing the process of cleaning and starting a new thread. As I told you, starting a new thread always takes some time. You may say it is nothing, but still, when the too many processes are going on, it can take some time. So we need to reduce that overhead, to reduce that extra time. We are creating a thread pool, saying that, hey, our program may require 10 threads at most of the time. So we can create a pool of 10 threads. So that way we don't need to always create a new thread and delete. I mean, garbage collector will not spend the time on the cleaning those parts. Okay. So in this thread pool, that thread pool is just only about this thing. Okay. So as I was saying that in thread pool, tasks are submitted to the thread pool for execution. So that entire part of doing the work is handled by the thread pool. What you say is, hey, this is my thread pool, 10 size. Hey, thread pool, this is a like you have created a runnable interface. As we have discussed, runnable interface is more like these are the steps which needs to be executed. You say, hey, this is the work which I need to do. You submit it to the thread pool, and thread pool get it executed by one of its thread. This is what we are trying to say in this one. Okay, the task can be represented as an instance of runnable or callable object. Okay, tasks are submitted to the thread pool using submit. So you just submit that steps or the instructions which needs to be executed to the execution pool, sorry, to the thread pool, and then that thread pool manages everything related to that, which thread to assign to to that runnable interface, and all that life cycle will be managed by that thread pool. And for that, we are going to use this execution service, which is again provided by the JDK itself. Here we can say, hey, execution service, create a thread pool of 10 threads, and whenever we have a task to do, we just submit the runnable interface or the callable object. We will discuss the callable object later on. For now, just we will stuck to the runnable interface. That, hey, we will just submit the runnable interface to the execution service, and it will always do the work for us. Okay. Now let's come to this shutdown. So when we are done with the, now again, this execution service also have a life cycle, basically shutting down. Let's say when we know that, hey, we are done with our own work, we can just call the shutdown function where all the thread pool will be released basically. Okay, so it says, like, for example, shutdown now, attempt to stop all the actively executing words, holds all the process, and return a list of the tasks that were this. So this shutdown and this shutdown, now you can just read this line more. There's nothing much in this to basically exactly discuss about those part. Down, whatever, if when we say shutdown, all the process which were running will be allowed to continue, but there will be never the new task will not be allowed to run. Okay, as I said, but continues to execute previously until they are completed. But we are not allowed to say, hey, run this new task. But in shutdown now, we just stop all the tasks at that point of time, basically. Okay, so we have this method in the execution service which we can use to shut down the everything. These are the two methods which we have there. Now we will just see the code now, how we can execute it. Let's go through it. Okay, so this is what we have. Let me try to do it this way. Yeah, okay. So in this example, if you see here on line number 8, we are saying, hey, create a fixed thread pool of size 3. That means create 3 threads basically. Okay. Now here what we are doing, whenever we are saying this work, this executor dot submit, we are passing this thing basically. This is the work which we want a particular thread to be done. Okay, try, catch, and all those things. So we are saying, hey executor, this is the instructions which we want to run. Please assign a thread to this and get it executed. Actually, if you see one thing here, ourselves we have not created any thread at all. Okay, we are just saying this. We have just written a simple statement. This will return the thread name of the current thread, which is actually running this entire function itself. Okay, so if you see, we have just provided the instruction here that hey, these are the instructions which you need to execute. So if you see here, we have not run it. I think let's run it. Task 3 started by thread pool 1 here. Okay, if you see task ID is coming up here, we have assigned the task 3, 2, and 1 to the thread pool now. And they have assigned some threads to those tasks which are getting executed. Now here if you see this one, task 3 started by thread pool 1, which is assigned to thread 3. Thread 3 is the name of that thing basically. Next one is task 2 started by thread pool, which is assigned to thread 2. The next is task 1 started by thread pool 1, thread 1. Okay, now what is happening is these are getting run under that particular thread scope. So that's why you are getting these thread 1, thread 2, and thread 3 differently. Okay, although they are, you may say, hey, thread is always same. No, these are run under a particular scope of every thread. Like once these instructions are run under thread 1, this is actually telling us that name of that particular thread. Once this entire instructions are run under second thread, this line is coming from that one. Once these instructions are run under by the thread 3, from there these instructions are coming up. These log lines are coming up. Okay, you can just think of it like a lambda here. We have just provided that, hey, this code is a kind of a code which you need to execute. This goes to each of the thread and then they execute it in their own scope. Okay. At the end, as we talked about shutdown, basically, it will start shutting down all of those threads. But this is not shut down now, so it will allow the other tasks to get completed, as it is mentioned here. Wait for all the tasks to complete for a specific timer, basically. Okay. What we are doing here is we are saying, hey, you are given 5 seconds, whatever. If the task can be completed in the 5 seconds now, great. Otherwise, after 5 seconds, we are just doing this thing. We are shutting it completely, blocking it within the timeout. So we are setting a timeout here. Yeah, I think that's the only thing which we have here in this one particularly. Let's see if we have missed out anything. I don't think so.